Pipelining is a technique to speed up processing of a processor. Justify this statement with the suitable example. Explain about cluster configuration. Pipelining refers to the technique in which given task is divided into number of subtasks that need to be performed in sequence. Each subtasks are performed by a given functional unit. The units are connected in a serial fashion and all of them operate simultaneously. The use of pipelining improves the performance compared to the traditional sequential execution of tasks. In general, the output of one element is assigned to the input of next element is pipelining process. Simultaneous execution of more than one instruction take place in pipeline processor. For example, there are 5 execution phases in instruction cycle: instruction fetch, decode, instruction phase, instruction decode, operand fetch, operand execute, operand store. Let I is the instruction given to the instruction cycle. This is the figure of non-pipelining. If we give instruction to the instruction cycle, first instruction fetch, instruction decode, operand fetch, operand execute, operand store. These are the phases in this instruction cycle, and we give I instruction first to these instruction cycles, and it completes the phases, all the phases, and after that we give another instructions. In non-pipelining process, after completing one instruction cycle, then only it takes another instruction. But in pipelining, whenever one phase of instruction completed, it takes another instruction. So pipelining gives better performance, throughput, and increased efficiency. Let's see the real life example. Let's consider a water bottle packaging plant. Suppose there be 3 stages that a bottle pass through. They are inserting bottle, filling water in the bottle, sealing the bottle. These are the stages. One stage takes 1 minute to complete its operations. In non-pipeline operation, in non-pipeline operations, a bottle is first inserted into the plant. In the plant, after 1 minute, it moved to the stage 2, where water is filled. Now, in stage 1 is not stage 1, nothing is happening. Similarly, when the bottle moves to the stage 3, both stage 1 and stage 2 are idle. But in pipeline operation, when the bottle is in stage 2, another bottle can be loaded at stage 1. Similarly, when the bottle is in stage 3, there can be one bottle each in stage 1 and stage 2. So after each 1 minute, we get new bottle at the end of the stage 3. So parallel processing can be happening in the pipelining. So it gives the high throughput, better performance, and it increases the efficiency of